Hi, this section is going to be entitled Sketching Quadratics in Vertex Form. It's an extension. We're still on an extension of Lesson 10.2, which was sketching quadratics in standard form. I apologize. The last couple of videos have been a little bit longer. I think I'll make up for it today for you. This video will be a lot shorter. All right. Let's quickly review what the types of quadratic forms that we have already sketched. Remember, we started the chapter off in section 10.1 and 10.2, and we were working with sketching in standard form. That's what 10.1 and 10.2 was over. All right. Y equals ax squared plus bx plus c. Now, a, b, and c all have particular meanings. Remember, if a was positive, the parabola opened up. If a was negative, it opened down. If a is a number greater than 1, it would stretch the parabola, which means thin it out. And if a was something between 0 and 1, a fractional amount, it made the parabola shrink, which in other words means the parabola gets wider and fatter, I guess you could say. All right. B, if b isn't 0, that means the parabola, the axis of symmetry, is being shifted left or right. Now remember, a negative doesn't necessarily mean moving left, and a positive doesn't necessarily mean moving right. It just, if there's a b value other than 0, it means that the parabola is being shifted left or right somehow. And then remember, c was the y-intercept. And we could use this little formula to find the axis of symmetry. From there, we did another extension lesson. We just completed that yesterday on intercept form graphing. And remember, in intercept form, A meant the same thing it did up here in standard form. A had the same meaning, okay? It just told us if the parabola stretched, shrunk, opened up, opened down. And then remember, P and Q were the intercepts, and I could use the intercepts to graph my parabola. That's what we just completed yesterday. The third kind of form that we would have to sketch is called vertex form. And you'll see it on page 669. Now here's what vertex form, it's very simple to graph. A has the same meaning that it did here and here. It just tells me, does the parabola open up? Does it open down? Is it stretched or is it shrunk? The vertex is found by looking at H and K. All right. In fact, the value of H and K, this gives you the vertex. Okay? So by looking at vertex form, you can just see the vertex. That's why they call it vertex form. By looking at it, it just immediately tells you what the vertex is. All right? Let's do an example problem. Here would be an example problem. We have negative 2, x minus 1 squared plus 3. So let me quickly draw an xy axis so I can graph this. So here's an xy axis. Okay, the first thing I notice, my vertex is right here. It's 1, 3. That's my vertex. Now you might be like, well, why are you saying 1? There's a negative out front. Remember, the basic form is negative. I had to have put in a 1 for h to make this x minus 1. So h is a 1. Vertex form is 1, 3 for the vertex. So over 1 up 3, my vertex would be about here. All right. Now remember, the vertex always lies on the axis of symmetry. So my axis of symmetry must be right here. I know my parabola is opening down. I know it's opening down because I have a negative value for a, so it's going down. Let's get one other point. If you plug in 0, we can find another point on our parabola. So let's plug in 0. If I plug in 0, I get 0 minus 1 is negative 1. Negative 1 squared is 1. Negative 2 times the 1 is negative 2 plus 3 is 1. So 0, 1 must be a point on the parabola. So I know that this 0, 1 would be about here. This thing must be opening down. Remember, I said down. And then I can mirror that point over here. Well, since the axis of symmetry is at 1, if I go over 1, I got to go over another 1. This must be the point 2, 1. There's a second point. That's not a great picture, but I think you get the idea. this has a maximum value right now of 3. So I've done all the things I've asked you to do at any time for graphing, or sketching, I should say, sketching a parabola. I labeled the vertex, I labeled the axis of symmetry, I labeled 2 other points, and I labeled if it's a maximum or minimum or what it is. Pretty simple. Here's another one. I want to graph this in vertex form. This is actually from page 670, part of the assignment, problem number 4. Okay, so step 1, there's my vertex. It's 1, -2. So I'll go over 1, down 2, put a point, and remember my axis of symmetry has to be right there. Can you see how this graph must open upward? Positive number. If you plug in 0, you can find out what the y-intercept is. So let's plug in 0. 0 minus 1 is -1. -1 squared is 1. 3 times 1 is 3, minus 2 is 1. So my intercept is 0, 1. It's just a coincidence that the first 2 problems I did had the same intercept. It doesn't always work that way. So I can mirror that over. This would be 2, 1, and I can graph that. This is opening up, as we said it should, and this has a minimum value of -2. All right? Another question, number 3. There's 2 ways we could do number 3, actually. Number 3 is in standard form. You could do number 3 with the way we learned in lesson 10.1. We could do this the way we learned in lesson 10.1. Remember, if B is 0 right now, that means the axis of symmetry is at 0, and we can use that to find our vertex. You can review 10.1. We could to graph that, or sketch it, I should say. So that's one way we could do it. Just do what you did back in 10.1. Or, now with what we've learned today with vertex form, we could also treat this problem in this way. We could just put a -0 in here. If you do, that's in vertex form. Can you see how the vertex is 0, 3? Let me actually graph that one. Vertex is 0, 3. So let me draw a XY axis. Here's my vertex, 0, 3, which would be about here. This graph is opening up. I got to get another point on the graph, so I tell you what, I'll plug in 1. Let's see at 1 what's y. So if I plug in a 1 here, 1 minus 0 is 1. 1 squared is 1. 1 times 1 is 1, plus 3 is 4. So the point 1, 4 would be on the graph, which means this has to be the point -1, 4. I forgot to draw my axis of symmetry. Let me do that. Got to get it in there. I'm always supposed to do that. My axis of symmetry would be right down the y-axis right now, so you can see these points mirror. And then finally, this graph would have a minimum value at, right here, I'm sorry, minimum value at 3, okay? So I've labeled all the things I want. There's my axis of symmetry at 0, minimum of 3. My vertex is 0, 3. I can label that here, vertex 0, 3. And there's 2 other points. All right? Just one last problem just to make sure you got the hang of it. This is in vertex form, and I want to graph it. So let me make an XY axis. Here's my vertex. It's -5, -3. Vertex is at -5, -3. So 5 left, 3 down, about right there. Let me draw my axis of symmetry. Remember, my axis of symmetry has to go right through that. So here it is. Axis of symmetry right now is at -5. I know this graph opens up because positive value for A. Let's find out what the y-intercept is. If I plug in 0, 0 plus 5 is 5. 5 squared is 25. 2 times 25 is 50, and 50 minus 3 is 47. So I got a point way up here at 0, 47. And I can mirror that point over here, way over here. It would be at -10, 47. Remember, the reason I'm getting negative 10 so quick is from here to the mirror is 5 units. So I got to go 5 units over here to get to the other point. Well, 5 and 5 is negative 10, right? Okay, and then you can see the parabola opening up. It's not a great sketch, but I'm doing my best. And this parabola has a minimum value at negative 3. Anyway, that's vertex form quadratic sketching, the third kind of sketching, and I believe the final kind of sketching that I will be having you do in this chapter. If we have questions, we can ask those in class tomorrow. I'm going to stop the video now.